Welcome, pre-med students, to a course on Gray's Anatomy. This is Dr. Meyer. Let's cover let's check out some of let's start tonight with the, the hemispheres of the brain. The lobes on the external surface have received their names from the bones of the skull, with which they are most nearly in relation. But it must be borne in mind that they do not correspond in shape or limit with the one after which they were named. The division is, moreover, to a certain extent artificial, as will be seen from the following description. If a line is drawn in continuation of the external parieto-occipital fissure downward and outward to the lower border of the hemisphere, it'll impinge on a slight notch, the pre-occipital notch. And if a second line is prolonged forward from the horizontal part of the fissure of Sylvius to join the first, the division of the outer surface of the hemisphere in 4 lobes will be accomplished. The portion in front of the fissure of Rolando is the frontal lobe. That behind the fissure, Rolando, and above the fissure of Sylvius is the parietal lobe. The portion behind the parieto-occipital fissure and its continuation is the occipital lobe. And the part below the fissure of Sylvius and in front of the occipital lobe is the temporal lobe. The fissures and lobes of the mesial and tentorial surfaces. The mesial surface of the cerebrum can only be fully viewed by dividing the corpus callosum and the structures beneath it longitudinally in the middle line in order to expose the tentorial surface. The pons varoli, cerebellum, and medulla must be removed by division of the crus cerebri on either side. Do you get it? When this has been done, a section such as is represented will be shown. The parts in the center below the corpus callosum belong to the interior of the brain and will be disregarded for the present while the lobes and fissures, the remaining portion of the hemispheres, are considered. The fissures are 5 in number, in addition to a small part of the fissures of Sylvius, the commencement of which is seen separating the frontal and temporal lobes. The fissures are named the colosso-marginal, the internal parieto-occipital, the calcarine, the collateral, and the dentate or hippocampal. The colosso-marginal fissure commences below the anterior extremity of the corpus callosum. So let's take a look at that on the diagram. Okay. It at first runs forward and upward, parallel with the rostrum of the corpus callosum, and winding around in front of the genu of that body, it continues from backward, between the upper margin of the hemisphere and the convolution of the corpus callosum, to about midway between the anterior and posterior extremities of the brain, where it ascends to reach the upper margin of the hemisphere, a short distance behind The superior extremity of the fissure of Orlando. The internal parietal occipital extends in an oblique direction downward and forward to join the calcarine fissure at a level with the hinder end of the corpus callosum. The calcarine fissure commences usually by two branches close to the posterior extremity of the hemisphere. These soon unite, and the fissure runs nearly horizontally forward and is joined by the parietal occipital fissure and continues as far as the posterior extremity of the corpus callosum. A little below the level of which it terminates. Its anterior part causes the prominence of the interior of the brain, known as the hippocampus minor or calcar avus. The collateral fissure is situated on the tentorial surface, below and external to the preceding, being separated from it by the subcollateral or uncinate gyrus. It runs forward from the posterior extremity of the brain nearly as far as the tip of the temporal lobe. Okay. It lies below the posterior and descending horns of the lateral ventricle, and its middle part causes the prominence in the interior of the brain, known as the emmenitia collateralis. The dentate or hippocampal fissure commences immediately behind the posterior extremity of the corpus callosum and runs forward to terminate at the recurved part of the hippocampal gyrus. It causes the prominence of the hippocampus major and the descending horn of the lateral ventricle. In addition to these fissures, which are constant, there is frequently an irregular broken fissure, which appears to be a continuation backward to the posterior part of the colossal marginal fissure, before it descends to reach the upper edge of the hemisphere. Okay, so that was a little bit of sample the hemispheres of the brain. Now I'm going to cover. Let's see. So you're going to be tested on this tomorrow, so you better be taking notes. Okay. Let's see. Are you paying attention? Okay. How about the internal structure of the medulla oblongata? Okay. All right. If the cranial nerves emerging from the medulla are traced into its substance, it will be seen that they divide each half into three wedge-shaped areas, which are named the anterior, lateral, and posterior areas of the medulla, and each of which corresponds to one of the subdivisions already described on the surface of this portion of the encephalon. The anterior area comprises that portion which is situated between the anterior median fissure and the fibers of origin of the hypoglossal nerve. On the surface of the medulla, this corresponds to the pyramid. The lateral area is situated between the fibers of origin of the hypoglossal nerve on the one hand and the fibers of the glossopharyngeal, pneumogastric, and spinal accessory nerves on the other. Okay. On the surface of the medulla, on its lower part, this area is single and is called the lateral tract. But in the upper part, an oval-shaped body, the olivary body, comes forward between it and the pyramid, pushing aside the lateral tract. The posterior area comprises that portion which is situated between the fibers of origin of the glossopharyngeal, pneumogastric, and spinal accessory nerves and the posterior median fissure. On the surface of the medulla, this area is marked by slight furrows, splitting it up into smaller columns. Those in the lower part of the medulla are named from without inward the funiculus of Rolando, the funiculus cuneatus, and the funiculus gracilis. In the upper part of the medulla, they are represented by the restiform body. Finally, the halves of the medulla are separated from each other by a medium septum of raphe. Each of the three areas is made up of gray and white matter. The former being derived the most, for the most part, from that of the cord. In like manner, the white matter is partly made up of longitudinal fibers continuous with those of the cord, and partly of transverse fibers which intersect them. In order to understand the internal structure of the medulla, it is necessary to describe the appearances as they are seen in the upper and lower portions of the medulla, since they differ considerably in these two parts. The lower part of the medulla. The first change in the internal structure is caused by the passage of the fibers of the cross-pyramidal tract obliquely through the gray matter of the anterior horn. As stated above, the pyramid is composed of fibers derived from the direct pyramidal tract of the anterior column of the cord of the same side. From the cross-pyramidal tract of the lateral column, the opposite half of the cord. Those fibers which are derived from the direct pyramidal tract and which in the cord lie close to the median fissure are in the medulla placed to the outer side of the pyramid, being pushed aside, as it were, by the interpolation of the fibers derived from the cross-pyramidal tract, which are much more numerous. The cross-pyramidal fibers ascend from the lateral column of the spinal cord and passing through the anterior gray corna and across the middle line from the inner part of the pyramid. In consequence of the passage of the white fibers through a substance, the anterior gray cornu is broken up into a coarse network, while one portion of it, the caput cornu, is entirely separated from the rest. Only the base of the cornu remains intact, close to the ventrolateral aspect of the central canal. The caput cornu, thus separated, is displaced laterally and comes to lie close to the caput cornu posterioris, or posterioris, which has also shifted its position. In consequence of this breaking up of the greater part of the anterior gray cornu, in which white fibers, a coarse network is formed, the anterior and lateral areas of the medulla, which is named the formatio reticularis. The posterior cornu also undergoes somewhat similar changes. It becomes subdivided by the passage through it of the sensory fibers of the columns of Gall and Burdock. These pass across to the opposite interior of the medulla, where they are seen to lie immediately on the dorsal aspect of the pyramids. In their passage through the posterior horns of gray matter, the latter becomes subdivided in a manner somewhat similar to what has been seen to occur in the anterior horns. The crossing of the sensory fibers is termed the superior pyramidal or sensory decussation. The caput cornu is displaced outward so as almost to reach the surface, where it forms a projection, the funiculus rolando, which enlarges above it into a distinct prominence, the tubercle of Rolando. Above the level of the tubercle of Rolando, or the caput cornu is separated from the surface of the hand of the fibers, termed the ascending root of the fifth nerve, and the external arcuate fiber, what? Arcuate fibers. The neck of the corda becomes broken up into the particular formation by the decussation of the columns of gull and burdock, and this means the caput is separated from the rest of the gray matter. Okay, I want to cover the female anatomy in this. My favorite part of the human anatomy. I like the female anatomy in particular because I'm very attracted to the female anatomy. Let's see. Let's check out the female anatomy. We've got the, let's see. Where the hell is I'm looking for the female anatomy. Okay, here we go. Okay. Muscles of the perineum in the female. The transverse perineum in the female is a narrow muscular slip which passes more or less transversely across the back part of the perineal space. It arises by a small tendon from the inner and forepart of the tuberosity of the ischium and passes forward, is inserted in the central part of the perineum, joining in the situation with the muscle of the opposite side, the external sphincter, and behind, and the sphincter vagina in front. Nerve supply. The perineal branch of the internal putti. By their contradiction, they serve to fix the central tendinous point of the perineum. The sphincter vagina surrounds the orifice of the vagina. It is analogous to the accelerator. Okay, it is attached posteriorly to the central tendinous point of the perineum, which blends with the external sphincter. Its fibers pass forward on the side of the vagina to be inserted into the corpora cavernosa of the clitoris. Vasculars crossing over the body of the organ so as to compress the dorsal vein. Nerve supply. Okay. So that was a little bit of example of the female anatomy. Okay, so let's see. Special types of gray matter. In the cuneus and the calcarean fissure of the occipital lobe, Kajal has recently described as many as 9 layers. Here, the inner band of Belanger is absent. The outer band of Belanger, band of Gennari, is on the other hand of considerable thickness. If a section be examined microscopically, an additional layer is seen to be interpolated between the molecular layer and the layer of small pyramidal cells. This extra layer consists of 2 or 3 strata of fusiform cells. The long axes of which are right angles to the surface. Each cell gives off 2 dendrites, external and internal, from the latter of which the axon arises and passes into the white central substance. In the layer of small pyramidal cells, fusiform cells identical with the above are seen, as well as ovoid or star-like cells with ascending axons, cells of Martinati. This area of the cortex forms the visual center. It has been shown by Dr. J.S. Bolton that in old standing cases of active atrophy, the thickness of Guarnieri's band is reduced by nearly 50%. 2. In the hippocampus major, the molecular layer is very thick and contains a large number of Golgi cells. It has been divided into 3 strata: A, S convolutum or S granulum, containing many tangential fibers; B, S lacutosum, presenting numerous lymphatic or vascular spaces; C, S radiatum, exhibiting a rich plexus of fibrils. The 2 layers of pyramidal cells are condensed into one, and the cells are mostly of large size. The axons of cells in the polymorphous layer may run in ascending, descending, or horizontal direction. Between the polymorphous layer and the ventricular ependyma is the white substance of the alveus. 3. In the rudimentary dentate convolution, the molecular layer contains some pyramidal cells, while the layer of pyramidal cells is almost entirely represented by small ovoid cells. 4. The olfactory bulb. In many of the lower animals, this contains a cavity which communicates through the hollow olfactory stalk with the cavity of the lateral ventricle. In man, the original cavity is filled up by neuroglia, and its wall becomes thickened, but much more so on its ventral than its dorsal aspect. Its dorsal part contains a small amount of gray and white matter, but is scanty and ill-defined. A section through the ventral part shows it to consist of the following layers from without inward. 1. A layer of olfactory nerve fibers, which are the non-modulated axons prolonged from the olfactory cells of the nose, and which reach the bulb by passing through the cribriform plate of the ethmoid bone. At first, they cover the bulb and then penetrate it to the end by forming synapses with the dendrons of the mitral cells, presently to be described. 2. Glomerular layer. This contains numerous spheroidal reticulated enlargements termed glomeruli, which are produced by the branching and arborization of the processes. of the olfactory nerve fibers, with the descending dendrite of the mitral cells. 3. Molecular layer. This is formed of a matrix of neuroglia, embedded in which are the mitral cells. This is formed of a matrix. Oh, okay. These cells are pyramidal in shape, and the basal part of each gives off a thick dendrite, which ascends into glomerular layer, where it arborizes as indicated above, and others which interlace with similar dendrites of neighboring mitral cells. The axons pass through the next layer into the white matter of the bulb, from which, after becoming bent on themselves at a right angle, they're continued in the olfactory tract. 4. Nerve fiber layer. This lies next to the central core of neuroglia, and its fiber consists of the axons, or afferent processes of the mitral cells, which are passing to the brain. Some afferent fibers are, however, also present and terminate in the molecular layer, but nothing is known as to their exact origin. The size of the brain was formerly said to bear a general relation to the intellectual capacity of the individual. Cuvier's brain weighed more than 64 ounces. That of the late Dr. Abercrombie, 63 ounces. And that of Dupuytren, 62 and a half ounces. Okay. On the other hand, the brain of an idiot, okay, seldom weighs more than 23 ounces. Okay. Okay. But these facts, okay, are by no means conclusive, and it is well known that these weights have been equaled by the brains of persons who never displayed any remarkable intellect. Okay. Dr. Heldon of Cincinnati has recorded the case of a guy whose brain weighed 68 and 3/8 ounces. He was never regarded as particularly intelligent. He was illiterate and is said to have been reserved, meditative, and economical. Dr. Enzer, district medical officer at Port Elizabeth, reports the brain of Carey, the Irish informer, weighed 61 ounces. The human brain is heavier than that of all the lower animals, excepting the elephant and whale. The brain of the former weighs 8 to 10 pounds, and that of a whale in a specimen 75 feet long weighed rather more than 5 pounds. Cerebral localization and topography. Physiological and pathological research have now gone as far as to prove that the surface of the brain may be mapped out into a series of definite areas, each one of which is intimately connected with some well-defined function. And this is especially true with regard to the convolutions on either side of the fissure of Redondo. Which is believed by most physiologists of the present to be concerned in motion. Those grouped around the fissure being associated with the movements of the extremity of the opposite side of the body, and those around the lower end of the fissure being related to the movements of the mouth and tongue. This is not the place or the space to be given to describe these localities. But the two accompanying cuts from Ferrier have been introduced and will serve to indicate the position of the more important areas. The relations of the cerebrum to the outer surface of the scalp has been the subject of much investigation, and many systems have been devised by which one may localize these parts from an examination of the external surface of the head. These plans can only be regarded as approximately correct for several reasons. In the first place, because the relations of the convolutions. Wait a minute. No. Okay. The surfaces are found to be very variable in different individuals. Secondly, because the surface of the scalp is greater than the surface area of the brain. And thirdly, because the sulci and convolutions in two individuals are never precisely alike. Nevertheless, the principal fissures and convolutions can be mapped out with sufficient accuracy for all practical purposes. So that any particular convolution can be generally exposed by removing with the trephine a certain portion of the skull's area. The various landmarks on the outside of the skull, which can be easily felt, and which serve as indications of the positions of the parts beneath, have already referred to, and the relation of the fissures and convolutions of the landmarks is as follows. Longitudinal fissure. This corresponds to a line drawn from the glabella at the root of the nose to the external occipital protuberance. The fissure of Sylvius. The position of the fissure of Sylvius and its horizontal limb is marked by a line starting from a point 1 inch and a quarter horizontally behind the external angular process of the frontal bone to a point 3/4 of an inch below the most prominent point of the parietal eminence. The first 3/4 of an inch will represent the main fissure, the remainder, the horizontal limb. The bifurcation of the fissure is therefore 2 inches behind and about 1/4 of an inch above the level of the external angular process. The ascending limb of the fissure passes upward from this point parallel to and immediately behind the coronal suture, the fissure of Rolando. To find the upper end of the fissure of Rolando, a measurement should be taken from the glabella to the external occipital protuberance. The position of the top of the sulcus will be measuring from in front 55.6% of the whole distance from the glabella to the external occipital protuberance. Professor Thane adopts a somewhat simpler method. He divides the distance from the glabella to the external occipital protuberance over the top of the head into 2 equal parts. And having thus defined the middle point of the vertex, he takes 1/2 of an inch behind it to the top of the sulcus. This is not quite so accurate as the former method. But it's sufficiently so for all practical purposes. And on account of its simplicity is very generally adopted. From this point, the fissure runs downward and forward for 3 3/4 and 3 3/4 inches will be mark the length of the furrow. Dr. Wilson has devised an instrument called a certometer, which combines the scale of the measurements for localizing the fissure with data for representing its length and direction. Professor Thane gives the lower end of the fissure, the furrow, as Sylvius. So that according to the anatomist, the line drawn from the point half an inch behind the midpoint between the glabella and the external occipital protuberance of the spot, he would mark out the fissure of Rolando. Dr. Reed adopts a different method. He first indicates, he then draws two perpendicular lines from his baseline, that is from the lowest part of the infraorbital margin through the middle of the external auditory meatus to the back of the head, to the top of the cranium. From the depression in the front of the processes at its root. He has thus described the surface of the head, a four-sided figure, and a diagonal line from the posterior superior angle of the interior perpendicular line, where it is crossed by the fissure of the Sylvius, will represent the furrow. Okay. So, wait, do I want more of this Grey's Anatomy, or you can move on to something else?